Hello class. So this is just a continuation sa lesson na to on transformer tests. But this time we will tackle first about the polarity test. So with the same with a lot of circuit or electrical elements, ang transformers po nato na po na siya polarities positive or negative. So kung magtanaw ta sa kana betang diagram or sa actual nga transformer mismo, gina-indicate na siya by dots kung unsa ang kanang positive or kung uh, unsa nga winding dito gasulod ang current. So man na siya ang gina-indicate sa dots na generally to indicate the polarity of our transformer. Then for single phase transformer windings, the terminals on the high voltage side are identified as H1 and H2. Then sa secondary, we have X1 and X2 as we can see in this diagram. Then to check the polarity, we will create a connection between the primary and the secondary uh, as what you can see in the second picture below. So, i-connect daw na to ang voltmeter sa negative sides of the two windings. If the measured voltage is the difference of primary and secondary voltages, then ang polarity na to is subtractive, and hence ang dots kung asa man sila na lugar is in its correct position or in its correct notation or placement. So tama ang iyang polarity. Otherwise, if the voltmeter measures the sum of the primary and secondary voltages, the polarity is additive and one of the dots must be placed on the other end, meaning na nabaliktad. So it's just a matter of replacing the dot para dili na kailangan i-replace ang transformer winding. So as easy as that para ma-determine na to ang polarity. But of course, kung mamalit ta og transformer, naka-specify dyan na siya daan. That's a standard industry practice for polarities of transformers. Now let's move to open circuit test. So we have this circuit test is actually two-pronged. We have open circuit and then the short circuit test. So for open circuit test, gina-conduct natin na siya in order to determine ang admittance, the exciting admittance of the transformer equivalent circuit. That's one. Second is ang no load loss or losses. Then the third is the no load exciting current or katong IO. And the fourth one is the no load power factor or cosine theta sub O or sub zero. While one winding is open circuited, usually ang high voltage winding daw ato ang ginapabilin nga open circuited. As a voltage at the secondary is applied. This voltage is the rated voltage at rated frequency of the transformer. Then measurements of voltage, current, and power are made with the instruments as they are placed sa diagram na makita nato karon. So naatay ammeter in series, voltmeter in parallel, and wattmeter in both series and parallel. So ina na siya pagka-connect. Then through the open circuit test, the following parameters are measured. Atong voltmeter, gina-measure niya ang applied voltage at the point sa kanabitong closest to the winding. Then ang ammeter na to is the exciting no load current or I sub 0. And then atong wattmeter is the open circuit power or the POC. But giingon diri, the leakage impedance is negligible in the calculations kay tungod gamay kayo ang kanabitang line current or the circuit current or the no load current. And then the core losses are also negligible, which means na ang atong open circuit power is equal sa core losses in terms of watts. So that simplifies our calculations from then on. Tapos, Mani siya ang equivalent na circuit diagram of a transformer on open circuit. So makita nimo ng R1 of JXL1, ang impedance is negligible, so dili na siya significant. So we only have I sub 0, which is the vector sum of the core loss current IC and the magnetizing current IM. So, isolve na to ang admittance by dividing the no load current I sub 0 divided by voltage, which is equation 4.6. Then equations 4.7 and 4.8 respectively shows the formula for solving the conductance GC, which is dividing the open circuit power or the core loss power by the square of the voltage. And then the susceptance can be solved using the admittance and conductance. And then the no load power factor is given at equation 4.9. So let's try some problem. So kani siya sa yun ra kay ni mabuo ra kay ni nga problem. The no load test on a certain transformer with its secondary terminals open yields the following data. We have 400 volts, 2.5 amperes, and 150 watts. So again, mana siya ang ato ang nara applied voltage, exciting no load current I sub 0, and of course atong open circuit power or POC. Mana siya ng mga parameters. Neglecting the winding resistance and leakage flux as mentioned, calculate first the core loss current, the magnetizing current second, and the third is the no load power factor. So, kani siya given ra ni tanan dito sa problem. So, solution, we have letter A. Our core loss current is I sub C. So, we can solve that using the core loss power, which is in this particular case equal to the open circuit power. Kaya mo na siya ang tumong sa open circuit test. And then this is equal to applied voltage V times the current IC. So masolve na to ang IC using the value of the power and voltage. So we have IC is equal to open circuit power excuse me, divided by voltage. So that's 150 watts divided by 400 volts, and that is equal to 0.375 amperes. So nanatay solution. Very straightforward na approach sa pag-solve ani nga problem. Then we have the magnetizing current IM. Ang IM na to is masolve na to using this concept kani equation 4.8. So we have to borrow the formula from our lesson 2 part 2. So from equation 3.2, we have the no load current squared is equal to the sum of the square of what they call this core loss current IC and the magnetizing current IM. So solving for IM, we have sa sulod sa square root, we have IO squared minus IC squared. We have 2.5 squared minus 0.375 squared. So that yields us with the real answer for the magnetizing current of about 2.5 47 amperes. So that's our final answer. And then our letter C, our no load power factor, na siya dari sa equation 4.9 nato. We have power factor is equal to cosine theta is equal to open circuit power POC divided by voltage and no load current. So that's equal to 150 watts divided by 402.5. So atong power factor 0 or no load power factor is equal to 0.15 lagging. So, ayan ninyo kalimti class na kung mag-solve tag power factor, kailangan ninyo i-indicate kung either lagging or leading or in unity ang atong resolve na power factor. Okay? So, this is again using equation 4.9. So, mana siya atong solution. Now, let's go with the short circuit test. Now, the short circuit test is conducted to obtain the impressed voltage VSC, the input short circuit current ISC, and the power input PSC. It is conducted by short circuiting one winding, usually the low voltage winding, and applying a reduced voltage at rated frequency. So diri sila nagkalahi ni kuan ni open circuit kay rated voltage man to kay open circuit pero kay short circuit we have a reduced voltage, otherwise maguba ang transformer kay short circuit man at rated frequency such that the rated current results. At least na lang tay rated current na ma-result sa atong testing. And mo ni siya ang diagram sa connection sa mga instruments sa ammeter, voltmeter, and wattmeter. So we have a few things to remember. Number one is that the exciting admittance is negligible because of the short circuit. So, ang katong exciting na kada exciting circuit or exciting admittance katong Y, kani siya, mawad-an na siya bili kay tungod sa short circuit kay naka-parallel or shunt man pud na siya. Then the second is that the input power is nearly equal to the combined copper loss in both primary and secondary windings. So, mo na siya nga to ang ma-result sa PSC. Then the third is the applied voltage is nearly equal to the voltage drop in the combined primary and secondary. So, ang VSC o gatong power PSC are representative for both primary and secondary windings. And then the equivalent impedance is given by dividing the short circuit voltage or the impressed voltage by the short circuit current ISC as shown in equation 4.10. Tapos makita nato dari sa diagram below nga negligible ang magnetizing circuit or kaning exciting admittance ang GC o BM. And in the equivalent transformer circuit, the equivalent series resistance and leakage reactance are given by equation 4.11 and 4.12. So, masolve na to si REQ, so equivalent resistance, series resistance, by dividing the short circuit power by the square of the short circuit current, and then the vector sum of we can solve the reactance by the equivalent impedance in equation 4.10. So dali ra kay na siya isubayan na formula class. Kani siya na mga solving is intensive jud sa formulas. Gihatag na siyang formula para dali lang ta maka-solve, okay? Then the short circuit power factor is solve using equation 4.13, dividing the short circuit power PSC by VSC and ISC, or the impressed voltage and short circuit current. Dali lang kayo na siya subayon. Then let's solve another sample problem. A 75 kVA, 230 volts to 115 volts, 60 hertz transformer was tested with these results. So ang iyang turns ratio is to 1 lang. So muna siya ang results sa open circuit test. Then we have the short circuit test. Determine A, equivalent impedance in high voltage terms, and then B, the same thing but only in per unit values. So letter A is mana siya ato ang ZEQ, or mali na siya pagkasuwat. Mana siya dari. So ZEQ. So mani is equal to VSC over ISC, or unsa na siya equation 4.10, then that's equal to 9.5 volts sa short circuit test ni divided by 326 amperes. So that is equal to 0.029 ohms. So mana siya atong ZEQ, or equivalent impedance. Then letter B, ang per unit niya nga kanang values, magsugod ta by subayon nato ang base quantity sa impedance. So we have the base value for volt ampere is given by 75,000 VA. Then we have the base voltage equal to, for high voltage, in high voltage terms, we have 230 volts. Then ang base current nato is simply dividing VA by V. 75,000 VA divided by 230 volts, we have 326.09 amperes, which is almost equal sa atong short circuit current. And then from there, masolve na to si base impedance by dividing voltage by current. So we have 230 divided by 326.09, and that is equal to 0.705 ohms. So muna siya itong base impedance. So masolve na to si equivalent impedance in per unit by dividing 0.029 by 0.705 ohms. So ang ato answer dira ay 0.0411 per unit. By the way, kani siya is borrowed from equation 4.1 sa kani nga lesson. So ano lang na siya kadali, class. I hope na dali lang ninyo masubay ang atong lesson. Bawat formula is already given para diretso na ta-attack sa problems. So if you have any questions, just leave me a message, and thank you.